So good morning dear students. So in the video வந்து periodic trends அப்படின்றத டிஸ்கஸ் பண்ண போறோம். So what do you mean by periodic trends அப்படின்னா as you move along a period, as you move from top to down of the group, what are the periodicity and properties that we are going to observe? Okay, like metallic character increases as you move from right to left of the periodic table. Where are the elements more metallic? Left hand side of the periodic table, there are more elements which are highly metallic by character, and when you come to the right of the periodic table, the metallic character diminishes and non-metals are there. Like this, we are going to discuss about the periodic trends. Okay, so let me just show you a picture. So look at this picture. In this picture, most of the periodic properties are described. Okay, so the first one to the left we have a atomic radius. So from the top to bottom, in the left side of the periodic table, in the first group, for example, starting from lithium, sodium, potassium. Okay, so as you come down, atomic radius, what happens to the atomic radius? Increases as it comes down. So the atomic radius increases as you come down the periodic table. From top to bottom of the periodic table, the atomic radius increases. So naturally, you know the reason why the atomic radius increases. முதல்ல atomic radius என்ன அப்படி நம்மளுக்கு தெரியணும். From the center of the nucleus till the last orbit, அதுதான் atomic radius இல்லையா? இப்போ first element, for example, lithium எடுத்துக்கிறோம். In the first group, lithium is the first element. So how many orbits are there? There are two orbits. The first orbit will have two electrons and the next orbit will have one electron. அப்போ two orbits are there. அதில் இமீடியட்டாக கீழே இறங்கி பார்த்தோம்னு வச்சுக்கோங்க, சோடியம் இருக்கும். சோடியத்தில் மூணு ஆர்பிட் இருக்குது, 2, 8, 1. Electrons are in the number, electronic configuration is 2, 8, 1, and therefore the presence of 3 orbits are there. So naturally the atomic radius has to increase, and that is what is happening from you come from top to bottom of a periodic table. Understand? So like that, we are going to discuss about ionization energy, electron affinity, non-metallic character, metallic character. Okay, so like this, these characters are going to be discussed in the video. Just we are going to watch it now. Okay, kindly watch the video, and after the video ends, we will have a discussion over the video.
Hello everyone. What if I ask you what kind of clothes you would wear in April? I'm sure you will prefer cotton clothes as it's too hot at that time. And in December, you will shiver if you don't put on your sweaters, right? Okay, just like temperature changes across seasons, in the same way, elements also show a change in the properties in the periodic table. These are called trends. So trends are measured in two ways, down a group and across a period. Okay, let's check them out one by one. As you know, valency is the number of electrons lost, gained, or shared by an element to complete its octet. Down the group, it remains the same, as all the elements have the same outer shell electronic configuration. But interestingly, across the period, valency first increases and then decreases. Why do you think this happens? If there are less than 4 electrons in the outermost shell, it is easy for atoms to lose electrons. That is why the valency first increases. Okay, let's take sodium for instance. What is easier, to lose 1 electron or gain 7 electrons? Of course, sodium can easily complete its octet if it loses an electron. Thus, its valency is 1. Same goes for magnesium and aluminium, whose valencies are 2 and 3 respectively. Now look at phosphorus. It can complete its octet either by gaining 3 electrons or by losing 5 electrons. So what does phosphorus do? Yes, you got it right. It will obviously gain 3 electrons. So on the same lines, look at sulfur, whose valency is 2, and chlorine, whose valency is 1. So if the number of electrons in the valence shell are more than 4, it is easier to gain electrons to complete the octet. So we can conclude that valency first increases and then decreases across the period, but it remains the same on going down the group. Okay, before we go to the next parameter, check this out. We have 3 different timepieces in front of us. Certainly, each of them tells us the time, but what is different amongst them? Of course, it's the size. That's exactly what happens with the atoms. Different atoms have different sizes. Atomic size is the distance between the nucleus and the outermost shell of an atom. As an atom is spherical, atomic size precisely tells us its radius. Atomic size is controlled by 2 factors: effective nuclear charge and number of shells. Both these factors work in opposite directions. Effective nuclear charge is a measure of the amount of positive charge in an atom. It increases with the number of protons in an atom. So across a period, though the number of shells remain the same, the effective nuclear charge increases from left to right. This force of attraction pulls the valence shell closer to itself, and clearly the atomic size decreases. As we move from top to bottom in a group now, both effective nuclear charge and number of shells increase enormously. But here the increase in the number of shells dominates the increase in the effective nuclear charge. Naturally, the size of the atoms grow. So in short, we can say that across a period, atomic size decreases and down the group, atomic size increases. Seems like you're getting the hang of it. Okay, let us now discuss about the next property, metallic character. As you are aware, metallic character is the tendency to lose electrons. Let's build a trend of metallic character together. Suppose that you are watching a movie on your TV and you want to control the volume. How would you do that? Of course, just adjust it using the remote. But what if I ask you to adjust the volume of your neighbor's TV? Not possible, right? The remote only works for a specific range. That's exactly what happens with the atom. When the valence electron is close to the nucleus exerts a strong attractive force over it, that is, a strong effective nuclear charge. This prevents the valence electron from escaping the atom easily. On the other hand, if the valence electron is far off from the nucleus, it can sneak out comfortably. What do you conclude from here? Yes, you're right. Larger the atomic size, greater the ease with which an electron can be lost. Hence, we can say that across a period, the metallic character decreases and down the group, it increases. Cool, isn't it? Okay, let's go to the next periodic trend. I'm giving you 3 compounds here. Surely, you would have seen them before as they are quite common. As we just figured, on going down the group, the metallic character increases. Now, since fluorine, chlorine and bromine belong to the same group, we can conveniently say that bromine is the most metallic and fluorine is the least metallic of all. So, if each of them had to pull an electron from hydrogen, which one would do it most effectively? Yes, you're right. It is clearly fluorine. This means that in a compound, elements do have a tendency to pull electrons from their partner. This property is called electronegativity. By now, you would have guessed the trend in electronegativity down the group. Most definitely, it decreases. But can you guess what would happen across a period? Absolutely. The electronegativity increases as we move from metallic towards less metallic elements. So we can conclude that electronegativity increases across the period but decreases down the group. Once again, let's take a look at all the trends we have discussed till now. Valency remains the same in the group. It increases and then decreases across a period. The atomic size increases down a group and decreases across a period. Metallic character of elements increases down a group and decreases across a period. And electronegativity decreases down a group and increases across a period. Wow, that was quite a discussion. I'm confident that with these trends, you can even predict many more properties of elements and their compounds. One such property is the nature of oxides of elements. Metals are known to form basic oxides, whereas non-metals are known to form acidic oxides. Now you realize how useful the trends of periodic table are? Okay.
So, okay, fine. I think you would have understood the periodic trends. Okay. If let me just tell you a few points which I think you would need it. If I look at the atomic radius part of it, I just told you, as you move from top to bottom of a period, bottom of a group, atomic radius increases. அது நேச்சுரலாக உங்களுக்கு தெரியும், லித்தியம், சோடியம், பொட்டாசியம், ரூபீடியம், சீசியம் இருக்கும்போது the number of orbits increase ஆகுதுனால atomic radius increase ஆகுது. But look at it, okay, at the bottom of the picture here. Atomic radius increases as you move from right to left. அப்படின்னா என்ன அர்த்தம்? left to right மூவ் பண்ணும்போது atomic radius decreases அப்படின்னும் போது இந்த கான்செப்ட் கொஞ்சம் புரியாத மாதிரி இருக்கும் உங்களுக்கு. நல்லா கவனிங்க. இப்போ இந்த பீரியட் எடுத்துக்கலாம். For that slightly ivory color box, one single box where hydrogen is there, and below that we have a lithium and a boron. இப்போ அந்த பீரியட் எடுத்துக்கிட்டோம்னா there are 7 elements in it இல்லைங்களா? அப்போ starting from lithium, then atomic number becomes 4, 5, 6, 7, 8, like that it goes on. இப்போ the last boxல பார்த்தீங்கன்னா 10 electrons இருக்கும். அது என்னது? ஹீலியம், நியான். நியானுக்கு வந்து எலக்ட்ரானிக் கான்ஃபிகரேஷன் என்னன்னா 2,8. okay, it is a noble gas and the electronic configuration of neon is 2,8. so the second periodல first element வந்து lithium, அதோட atomic number 3. the next element is boron, atomic number is 4. like this it ends with the neon, atomic number is 10. இப்போ what happens to the atomic radius? That is a question. So left to right, the number of electrons are keeping on increasing. When there is an increase in number of electrons, நம்மளுக்கு நேச்சுரலா அட்டாமிக் சைஸ் பெருசாக தானே இருக்கும் அப்படின்னு ஒரு ஃபீல் வரும் இல்லையா? இந்த கொஸ்டின் எல்லாருமே கேட்கணும். இப்போ லித்தியத்தையும் போரானையும் கம்பேர் பண்ணும்போது which is having a larger number of electrons? boron has. அப்போ neon, the last element in that period, will be having more electrons. Up naturally the size of the atom should be bigger, but what is it? It is explained here. It is smaller when compared to lithium. Neon is smaller in size. Okay, that means the atomic radius is smaller when compared to lithium. How can this happen? அப்படின்னு நம்ம கேட்கலாம் இல்லைங்களா? இப்போ அதை தான் வந்து நியூக்ளியர் சார்ஜ் வச்சு நம்ம எக்ஸ்பிளைன் பண்றாங்க. இப்போ லித்தியத்தோட நியூக்ளியர் சார்ஜ் என்ன அப்படின்னு பார்த்தோம்னா, நியூக்ளியஸ்குள்ள 3 பாசிட்டிவ் இருக்கும். 3 positive protons are there, and therefore the 3 electrons are being pulled towards இல்லைங்களா? அப்போ லித்தியத்தோட செகண்ட் ஆர்பிட்ல ஃபர்ஸ்ட் எலமெண்ட், லித்தியத்தோட செகண்ட் ஆர்பிட்ல எத்தனை இருக்குது? ஒரே ஒரு எலக்ட்ரான் தான் இருக்கும் இல்லையா? இந்த ஒரு எலக்ட்ரானை வந்து நியூக்ளியஸ் வந்து அட்ராக்ட் பண்ணுது. ஓகே, பட் the next one, boron, will be having 2 electrons in the second orbit. But what happens to the nuclear charge? It increases also. There are 4 protons now. So they are able to pull the electrons much closer. When it is a question of neon, neon will be having 10 positive charges in this nucleus, and the outermost orbit, that is the second orbit of neon, will have 8 electrons in it. So what happens, since there is more number of protons inside the nucleus, the 8 electrons are brought very closer to the nucleus. Therefore the radius of neon is smaller when compared to the radius of lithium. That is the explanation for the diminishing atomic radius as we move from left to right of the periodic table. இந்த கான்செப்ட் நம்மளுக்கு புரியணும் இல்லைங்களா? அதே மாதிரி தான் non-metallic character increases as you move from left to right on the periodic table. Okay, so the left hand side of the periodic table, most of them are metals. On the right hand side of the periodic table, we have non-metals. Okay, so this is the explanation that they have given you. Understand? Hope you understand the periodic trends, and this is a very important question in your 10th standard, and therefore kindly try to understand the concepts and then learn it. Okay, so with this video, the periodic classification of elements is over. Concepts regarding the periodic classification elements are over. Now we are going to move on to metallurgy. Okay, so thanks for watching.